Today we will discuss interesting property of about rotation matrices. Here there are three frames: frame A, frame B, and frame C. They are at the same location. The origin is same, but for simplicity, for comfortability, we have drawn separately. But the origin is same. This one is frame A. It is coincides with the stationary frame. The orientation, 3D orientation of A frame is this type. This one is X, this one is Y, and this one is Z. Orientation of B, X is here, Y is here. So if we rotate this frame, along Z axis, Y, X to Y, this way, X to Y, this way, it becomes B frame. So we have made rotation X to Y around Z, so RZ 90. We get rotation matrix for B frame with respect to A. And now for this frame C, we have rotated further this frame C. Now we are rotating X to Z around Y, this one, this frame C, it becomes this frame C, X to Y. So X to Z around Y. So this one RY minus 90, initially RZ 90, and then after RY minus 90, we get the orientation of C with respect to A. And this is body field rotation, so we have taken successively. So this is the rotation matrix for C with respect to A. This is the rotation matrix for B with respect to A. And A coincides with S frame. So RA is actually RSA, we can say that. But it coincides with the station frame, so its rotation matrix is identity matrix. Now, what about RAC? Rotation matrix of C with respect to A. That is orientation of C with respect to A. So C we have already done. This one is X, this one is Y, and this one is Z. Initially we have rotated X to Y around Z. This way, X to Y around Z. It becomes B frame. X to Y around Z. So RZ 90. And then after, we have rotated this frame X to Z around Y. So it is RY minus 90. So we get this vector. So RC is nothing but RAC, orientation of C with respect to A. What about orientation of orientation of C with respect to A? Now what about orientation of A with respect to C, opposite to that? So this one is C. Now if we rotate this way around Y, around Y, Z to X, so it is RY 90. And then after if we rotate this way around Z, so Y to X, so it is RZ minus 90. If we multiply these two rotation matrices, we get this. Observe this, RAC and RC are transpose of each other. What about RAB? So for B frame, rotation matrix for B with respect to A. So A is this, and we have rotated this frame 90 degree around Z, X to Y. So RZ 90. So RAB is RZ 90. It is 0 minus 1 0 1 0 0 0 0 1. What about RBC? The orientation of C with respect to B. So initially B is this, and then after we have rotated around this X to Z. So RY minus 90 for this, or it is 0 0 minus 1 0 1 0 1 0 0. If we multiply these two vectors, these two rotation matrices RAB into RBC, we get RAB into RBC, we get 0, -1, 0. You can verify this 0, 0, -1 and 1, 0, 0. We get this if you multiply these two, and this is nothing but rotation of C with respect to A. So the rotation symbol RAB stands for orientation of B with respect to A, RBC stands for orientation of C with respect to B. So BB cut out. So we get RAC. So this rotation is very helpful for our maths. Opposite to that of rotation does not help much. Okay.